Yeah, let's start again with a new topic. Of course, we have seen Docker Compose to create multiple containers. This is fine. This is fine. We are, you know, write on, ML file and everything created, blah, 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 all these things, which are okay. Now, this is the last topic in Docker actually, called Docker Swarm. Of course, before going to Swarm, what is a Swarm, what it will do, we need to know few topics. First thing is high availability. What the hell is this? Because this is most important actually, not most important, everyone uses this, means it's mandatory, not important, it's mandatory. What is available? Let's say in simple terms, this may be a professional definition, but let's keep it simple. Imagine we have a backup. See, we have power backups, right? Or any kind of data backup, whatever it is. We store, why we store it? So if one thing is lost, another thing is there. If one thing is gone, another thing is still exists, so that we can able to use it. What if it comes to servers or application level in IT? That's what we call high availability. Simply what we do is we make high availability means we make sure that the application, whatever we are using, or service, whatever we have deployed, or the system, whatever we have, will make sure that it will be accessible always. It should be running always to reduce the downtime. So imagine Facebook or Google or YouTube, whatever these big giant companies, right? Imagine if the Google is down for 1 hour. Have you ever seen that? You don't see, right? Imagine, or YouTube or something, anything, take anything, Twitter or Instagram, whatever it is. Have you ever seen Instagram or down for 1 hour? The influence go crazy. Why? How they maintain that then? Of course, sometimes it'll get down by 1 or 2 minutes maximum, but how they it'll be back up online. But how they maintain that? They use the concept called high availability. It's a concept, not a tool. Actually, it's a concept. There are multiple tools which provides this concept, but yeah, it's a concept really, not a tool. This high availability concept, the main goal of this, as I told you, right, reduce the downtime and make the application or system available always. Let's say, let's take one application, maybe Google. It's running 10 containers. Of course, it will be running million, but yes, just for example, we have an application, it's running 10 containers. If all 10 are down, application is gone. If let's say two are down, application is running, but the performance became little slow because uh, the, the 8 containers cannot handle the traffic. See, as of now, we are running only one container because one container is enough for us. But for Google, it's not enough, right? Or for other application, big application, one container may not be enough to handle the traffic, incoming traffic. Correct? That's why we'll create multiple containers. So now imagine our 10 containers are enough to handle the traffic. Out of that, 5 are down, for example. So 5 cannot handle it. Application performance is bad. Now we'll be creating 5 again manually. 5 are down, so we created 5, total 10 again. Again, some are down. We'll create those things again. We'll replace those. This is a process of high availability actually. But one thing here in this, instead of we creating the containers or we making the application manually up, this high availability concept will make sure the design number or whatever the desired goal which we wanted, this will achieve automatically. It means my application need 10 containers. For some reason, two were down. For some reason, I don't know. For some reason, two were down. Automatically, it will replace those two with the new two. It will delete those two and add the new. Sorry, it will add the new two first and delete the old one, whichever is not responding. That's what high availability does. High availability, HA we call it. Everywhere we use it. Everywhere we use it. Docker also we have. That's why I'm telling you. In upcoming tools also we use high availability. Even servers, we are using systems, right? That also will maintain because one system cannot handle everything, obviously. That's called high availability. making sure the application or system is up and running always with less downtime. With less downtime is called high availability. System means take in server, take application, whatever it is. Correct? That's that's about high availability. Why I'm telling this now? Because the next concept what we are going to discuss uses this idea, works on this idea. Got it? That's about high availability. And there is something called load balancer. You may ask, we have discussed high availability, right? Okay, I told that we'll run 10 containers. So it will maintain the application uptime. I mean, it will make sure that application is accessible always, even though one is down. So still remaining are there, it will handle that, they'll handle the traffic. So one will be created again, whatever it's fixed. It is good. High availability is good. But imagine now, see, now we are running one container. We are accessing with the IP address, to open the application. But what if there are 10 containers? How do we access the application now? So we have 10 containers, Tomcat containers. How do we access the application now? What is the entry point of it? Entry point means how do you access it? That's when this concept called load balancer. Load balancer. What does it mean is maybe image is might be there. This will be helpful. Which one? Which one? An easier one. Yeah, maybe this one. This is very simple. So what happens now? Yeah, this imagine these are containers or servers. Your application is running inside it. So now imagine there is no load balancer. I think whatever the left side we are saying, they does not exist. How do we access these three servers? We cannot access. Of course, we can access only one at a time, not three. But there is something called load concept called load balancer, where we'll create a load balancer on top of our containers, on top of on top of our containers, on top of our sys servers, wherever depends. So this one, this load balancer, what happens is we create it. It will handle the incoming traffic. Now this will become the access point. So we don't need to access the server IP address or container IP address or hostname anymore. We create a load balancer. That load balancer automatically sends the traffic to all these servers, all these containers, whatever it's there. So now this is the access point or entry point, whatever you call it. So this load balancer will have an URL or IP address which will access through that. So what happens now? See, users, mobile, laptop, or iPad or anything, it will go to their open website. Website, the request will go to, instead of directly going to servers or containers, it will go to load balancer. Just a minute, sorry. Sorry. Yeah. So yeah, instead of we accessing the containers directly or application directly, we create a load balancer in front of it so that we can access application through load balancer. But you may ask, why the hell we need, what the hell load balancer is doing here? Why the hell we need to use the load balancer? Because load balancer can route the traffic to all the, no matter how many containers or pods, whatever exist, it will route the traffic to all of them. There are some certain methods how will you how it will route the traffic, like round robin. Round robin, one of the most famous thing. What does round robin means? If I, let's say I access the website, load balancer will send to the request, whatever request will send to server 1. Another user came in, it will send to, the request will send to server 2. Another user came, the request will be sent to server 3. Like that, round robin, one by one, one by one. Now three servers are full, right? Now again it will go to server 1 to 3, 1 to 3, 1 to 3, 1 to 3, like that it will keep on going. So that this concept is called round robin, which load balancer uses. Got it? So what happens generally? What happens is load balancer apart from all these things. When you open any website, let's say open this website or Google or something, it will establish a connection between you and the server wherever the application is running. Through that only the request will go. See here now, I open this website Geeks for Geeks. When I open this, it will create communication, a connection between me, my laptop, my network, and to this website wherever it's running the server. Obviously, it will be running on somewhere, right? Container or whatever it is. So through that, it will send a request. Hey, someone open this URL. It will send the request, and like this, it will go to load balance to server wherever it's running. Correct. So load balancer will handle the incoming traffic because once we have multiple containers, multiple servers, there has to be some access point, some entry point to use that. So at the time, load balancer will be useful. See, this is not only the use case for load balancer. We need load balancer actually. This is not like as I told you, important thing. It's a mandatory thing. Everywhere, see, we are running 300 containers for one application. Without load balancer, how can we access that? Those containers, right? We have our real-time scenario, we have 312 or something current yesterday when I seen. Which container do I access? I mean the application, whatever it's running. That's why we create load balancer in front of it. Where it will receive the traffic and it will transfer the traffic accordingly. It will share the incoming traffic to all the servers or containers, whatever present in, you know, inside the containers. I mean, here if you see there gave what will happen if there is no load balancer? See, this is a load balancer, right? Without load balancer, see, requests are going to one particular server, it's overloaded. Remaining all are free because we are accessing now directly server. There is no load balancer. We are accessing through server IP address or a host name maybe. But with load balancer, see, the traffic is being distributed. This is a clear image, maybe you'll understand. Now, traffic is being distributed evenly across all the servers or containers. Got it? That's how. That's why the load balancer is required. See why I am telling high availability and load balancer now? Because these are the base. These are the base for any application. Any application. Without this, there won't be any application deployed. You will never see any application. Take anything without load balancer, without high availability, there won't be any application deployed. There won't be any. You may deploy Tomcat container with some application without load balancer, without high availability idea concept. They won't. No one will deploy their application. Why I'm saying is because that's how we use it. That's how everyone uses that. That's important. That's how mandatory it is. Got it? And now these concepts will be using. No, this high availability concept we never used it so far, right? Because we haven't got a chance. Or load balancer also. These concepts will be using in our new topic called Docker Swarm.
So,
Sorry, resound or something. Can someone mute, please? Sorry. Thank you. So, what is Docker Swarm? It's a cluster concept actually. It's a cluster. To keep it simple, it's a cluster. You may ask, what is cluster now? What is a cluster? Simple. Without Docker, just imagine what is a cluster means. Group of something called cluster. Group of something called cluster. Group of anything. Let's say group of. Why the swarm? The name swarm is like, let's search Google the swarm. Just swarm. Ah, it came with TV series? No, right. Okay. Swarm is a large number of individuals or things such as insects or people that are massed together and often in motion. It means group of something is called swarm. In other words, in IT industry, we are in IT and all, we call it cluster. Group of something is called cluster. In IT terminology, why we call it cluster? Because here we're talking about machines, right? We're talking about machines, we're talking about servers. So that's why the name cluster. Swarm is group of anything. Cluster, group of anything. But we use cluster because group of servers. Got it? Cluster means group of server. Sorry, I was drinking water. Just a minute. Yeah, sorry. So now this, why this concept is here, Docker Swarm now. Of course, we know now it's a cluster. It means group of servers. Why it is required now? Why it is needed now? So now what happening is, so far we are practicing, I mean, we are deploying our containers and everything in one, what is it? In one host, right? Now we got requirement, new requirement now. We want to set up load balancing, high availability, all these concepts, because one host is not enough for us. One host is not enough for us. We need multiple. We need multiple hosts. Why? Because our containers keep on increasing. See, imagine now this laptop, maybe whatever server. Let's not don't say laptop, server. I want to run 50 containers. It's not possible. It cannot handle. Why? Because why I need 50 containers in the first place? Because I need to set up high availability between them. I need to set up load balancing for that because my application requires 50 containers. It's not possible, right? So what we do, we'll create multiple servers and we'll install Docker every in those servers and we work on it. Correct? But here the servers are there, but they're individual servers. They're not together. They're not talking to each other. They're not together. That's where this concept comes, cluster. Cluster means group of something where group of clusters, sorry, group of servers, as I told you, group of machines where they communicate each other. That's where we call it cluster. That's what we call cluster. That why we need cluster to manage multiple containers, because one system cannot handle it. Servers, nodes, we sometimes we call it nodes. Docker node, I mean, or Jenkins node. Well, that are the server. Don't get confused about it. All right. So this Docker Swarm concept, it's Docker Swarm is a cluster actually concept in Docker, where we'll run multiple servers. We'll group them together as a cluster so that they'll talk to each other. They'll work as a group now. Imagine there is a cricket team or something. They'll work as a team, right? What their goal to win something, to win the match. That's their goal. Here also Docker Swarm, it's a cluster. What the goal? To manage the containers. That's the thing. To manage the containers. For, depends on how many. It depends on the resources or everything. But yeah, to manage the containers. How do I do it? I mean, how do I manage the containers? How do I manage the containers? How do I deploy our containers? How to set up load balancing? How to set up high availability? All that we'll see tomorrow. Don't worry. For now, today, why I'm giving you is I'm just giving you idea about basic concepts of Docker Swarm, which we're going to discuss tomorrow. That's why I'm just giving a little heads up. We have instead of Docker Swarm nowadays, people use something called Kubernetes. It's a cluster. It's a separate tool outside of Docker, which we'll discuss later. But yeah, for now, Docker Swarm. Docker Swarm is a cluster. Is a cluster where we used to manage our Docker nodes. I mean, our Docker containers on top of them. All we have to do is we need to have multiple servers where we enable the cluster and we make them work together. That's it, and we deploy the containers. Don't worry, this we'll see tomorrow, the setup and everything. For now, the only the introduction, as I told you. If you see here, Docker Swarm is a native clustering and orchestration solution built into the Docker engine. It enables you to create and manage a cluster of Docker hosts. It means Docker machines. Cluster means multiple, as I told you, referred as Docker Swarm, and deploy and manage container applications as services across these hosts. Now what happens is, I'll just give one small thing. It is one mission which we are practicing. Okay, this is fine. Now imagine that we have multiple hosts, multiple servers in the cluster. So the container can run anywhere in those servers. Let's say I have three servers within the Docker cluster. Now I'll create a container. That container can run anywhere in the three machines. That's how cluster works. How it can run in anywhere of those three machines means, as I told you, it's a cluster means whatever no matter how many servers are there inside it, they are communicating each other, they're talking to each other. So the container can run anywhere. That we'll see tomorrow, don't worry. But for today, I'm just want to give you idea what is this. Got it? Please someone mute it. So that's why these concepts I told today, Docker, what is it? Docker, high availability, load balancing. Now, what is Docker Swarm? What is cluster? All these things. Got it? Any questions so far on the introduction? I mean, of course, we will we'll do this real-time testing and all tomorrow, don't worry. But yeah, this is just an introduction call. So any doubts so far?
Okay. The load balancer also having what? Load balancer also easier on the server.
Load balancer is not a server, it's a service which we create. So what happens is, load balancer is a concept, as I told you. High availability is a concept, load balancer is a concept. So what we do is, this concept, whatever we discussed, will be provided by the tools, whatever the tools we are using. Let's say I want to use a load balancer. I want to create a load balancer. There will be few services which will provide this load balancer concept. Example like Nginx is there, right? Nginx also we can use as a load balancer, because this feature, this load balancer feature is available in Nginx. That's why, that's how we can able to use it. Similarly here also, Docker Swarm or Kubernetes or whatever any other tools provides this load balancing concept. It's a concept, it's not a separate tool, it's a concept where every tool now gives you, now, so that you can able to use this idea for your applications. It's not a separate tool, it's a concept. High availability is not a separate tool, again, it's a concept. It's a feature. This feature provided by multiple tools in the market available. Got it? Any other doubts so far before we close the call? Say it, yeah. Anything. If you ask, or ping me, that is also fine. All right. If no doubts, we'll have class tomorrow, 6:45, same time. I'll update the link. I'll forward the link. So please join so we can close the topic tomorrow, because Monday we don't have any class. I won't be available. We'll start from Tuesday again with a new tool. But yeah, Docker Swarm topic we can close to. It won't take much time, so we can close tomorrow, 6:45 a.m. Not p.m. Sorry. We can close it faster. That tomorrow Sunday. I don't want to take too much time of yours. Got it? Let's join by 6:45. Don't wait until 7 or 6:50 something. I'll start by 6:45. Please join. We can close it. So yeah, that's all about today's class. Let's implement this Docker Swarm, load balancer, high availability tomorrow. Let's see all of them. All right. Happy weekend. Bye all. Bye.